Question 3 is on tools, which is a specific topic, which is specific to fitting and machining. Question 3.1, they said name 3 ways in which hardness is measured. So you'll remember the second last week of school, I said that you had to mark this in your textbook. All of this work that's important. On page 98, you'll find the ways that hardness is measured. So resistance to penetration, elastic hardness, and resistance to abrasion. Those would be your 3 marks that you would have gotten there. Then 3.2, discuss the method or principle of the Brinell hardness testing. So that is the way that they, or that the Brinell hardness tester works. So that counted 4 marks, but there's a lot of things that you could have said, and I would have chosen the 4 marks for you then there. So you'll see on page 99 is your Brinell hardness tester. So the first mark that you would have gotten is to say that it involves indenting the material with a 10mm hardened steel or carbide ball. So that was 1 mark. Then the second mark, it's subjected to a load of 3,000 kilograms. All for softer materials, 1,500 kilograms or 500 kilograms. So those would have been your second mark. Then for how long it's applied, 10 to 15 seconds is the third one, or 30 seconds then. Then to say that they take the test material under a microscope to measure it again is another mark, and that they measure the area is another mark. So you could have said anything there for 4 marks then. Then question 3.3, discuss the function and principles of a moment of force tester. So you'll find that on page 103. So basically they wanted those 2 things there, the function of it. So to determine the reactions on either side of a simply loaded beam. So to determine the reactions was 1 mark, and on either side of a simply loaded beam is another one. And then to illustrate the concept of the triangle of forces would have been your 3rd mark over there. Then 3.4, sorry. This draw a neat sketch of a depth micrometer depicting 28.26 millimeters. So remember, my micrometer only measures from 0 to 25, 25 to 50, and so on. This is more than 25, which means it's the second size of micrometers. So you could have either went on from 25 up until 50 on your scale that you draw, or you could have started at 0 again, but then you had to show somewhere on the sketch that it's a 25 to 50, then it would have been fine. Okay, so I used the 25 to 50 range. So remember that a depth micrometer gets bigger in the opposite direction. So my outside and inside micrometer goes bigger to the right and to the top, where this is in the opposite direction. So anything you see over there, because it's moving to the left, you can't measure anything of that because it's not there yet. So because it's 28 is the last thing that it measured. So 28 is going to be over here where you can't see it, which means my next full millimeter is 29 and then 30. That's why you are seeing those. It's 0.26. It's not a half yet, so you could not have indicated a half there. So that's why the half is not there where you can't see it, but you can see it. Because 28 is there, then you would get the half, and then you would get 29. And then my 100th of a millimeter is then on 26. So you have to show 25 and then 26 up until 30 for your marks.